I had somebody email me in the 109 class, what did you go over Friday? Because we don't meet on Friday. Y'all don't meet on Friday, but the 109 does. I wasn't able to come to class. What did you go on Friday? Did I reply? Hell to the no. Well, that's what the damn videos are for. Duh. I don't understand people. Simple ass directions. Right, Miss Martinez? All right. So what am I going to go over today? I wanted to talk to you about chapter 2. Chapter 2, you may see that I've done away with it. Have y'all seen that homework that I've done away with it? I'm in the process of revising it. I will probably finish revising it this afternoon. It will be just one section. Oh, wow, you got my video on. What a hypocrite. Why did my video turn off? One homework from chapter 2. Now, if y'all want to do 6 homeworks, I'll give y'all 6, but I was going to get it narrowed down to 1.
Dr. Hubert?
What?
I've been here. I'm having internet problems. I just wanted to make sure I made attendance.
Yeah, as long as you you got your video on?
Yeah, I can turn it on.
Well, yeah, please do. It's mandatory. 1, 2, 3, 4. I'm looking to see because we had a few people add. Thank you. All right, now, chapter 2, I'm in the process of revising it into one homework assignment. Is that good for y'all? Or do you want 6?
1 is good.
Okay. Why am I not? Because you don't need to be doing, this is a 5-week class or a 10-week class. We need to get going, okay? And I would much rather spend the time on the calculus than spending time on limits, because you don't need to spend 6 assignments on limits. All right, so it's called something like Hubert's Chapter 2 Homework Revised. Okay. It will probably be uploaded tonight or tomorrow, because I'm going to either go over it depending on the homework problems that you've sent me, depending on the time. I don't know if I'll go over limits today or tomorrow. Is everybody okay? Everybody got that? So I know that some of y'all run around in circles hitting the walls, and because you're worried about the chapter 2 homework. Hubert took it off. Oh my God. Okay. Take some medicine, please. I told y'all that before I took it off. I told y'all that I would revise it. Did I not? Okay, so
yeah, you
look
did.
for it. Look for it. Maybe this afternoon or evening, I'm sorry, the night, or tomorrow. And I don't know how to spell tomorrow. I always want to put too many letters in it. So either this afternoon, evening, or tomorrow, I'll be posting, and it'll be just one section of homework, just one. Okay. Questions on that? And then hopefully by the middle of the week, we can go over the test, or the end of the week, we can go over the test and get out of this algebra review / limits and get into calculus next week. Capiche?
I have a question.
Yes, ma'am.
What's your test?
What was the question? What?
When is our test?
When we finish doing the homework and chapter 2 homework.
Okay, so like right now it's still undecided?
Yes, undecided. I'm trying to see who's, Miss Gonzalez, is your video on? Because I don't see you.
No, but I can turn it on.
Yes, please do. Okay. Video is mandatory. All right. I've had to tell everybody to turn their video on, Miss Gonzalez, not just you. I've had to tell everybody that. I don't know why. I'm trying to see, 1, I want to see everybody, and 2, I want to see if Teams handles it. 1, 2, 3, 4, 5. That's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. It is. It is covering it, and that's great. Okay, so here we go. Let's go with the questions that are being sent. Well, we're going to start with 1.3 because I went over 1.2 last week. So I'm going to get into a little bit of 1.3. Everybody with me? Yes, Hubert, we're with you. Good. Thank you for interacting. Okay, this is 1.3. Let me see if there's one. 1.3, number 3. 1.3, 3/2. So this is like number 2 online in 1.3. Determine which graph is 1-to-1 on the internal, on the interval negative infinity to -5, negative infinity to -5. I'm writing it down while y'all are writing it down. But is not 1-to-1 on negative infinity to positive infinity, but is not 1-to-1 from negative infinity to positive infinity. But it is 1-to-1 from negative infinity to -5. All right, first of all, let's go over the vertical line and the horizontal line test. Okay, let's go over that right quick for those that have forgotten it. Let's say you've got a function that looks like this. A vertical line test. Can somebody tell me what the vertical line test tells us?
If you draw a function or draw a line, it shouldn't intersect more than once on the
Exactly.
function.
This is not a function. Okay, the vertical line test establishes whether you have a function or not. This is not a function, okay, because it has 2 intersections, okay? So the vertical line test tells you if you have a function or not. So what does the horizontal line test tell us? The horizontal line test tells us if we have a 1-to-1 function. The horizontal line test tells us if we have a 1-to-1 function. This is not a 1-to-1 because it has 2 intersections. So the horizontal line test has to cross it 1 time for a 1-to-1 function, and a vertical line test has to cross it 1 time for a function or not. Function, 1-to-1 function. Now that's just, giving you a little bit of before we get started on this problem. Now, the problem says, and this is a test question, even though I probably wouldn't put it on there, it's not, let's see, from negative infinity to -5. Let's see where negative infinity is to -5. Negative infinity is right here. Positive infinity is right here, and we're talking about x, so negative infinity to -5. So somewhere in here, or somewhere in here, they're asking you, is it a 1-to-1? Okay, but the rest of it is not. So from here, here is not a 1-to-1. Everybody understand? Not 1-to-1. But from here over to negative infinity, it is 1-to-1. Question, right, complaint. So look at the, let's look at the homework. And this one goes past, this one right here goes past -5, so that's not it. This one right here, -5, it works right here, but it's also a 1-to-1 here. If you draw your horizontal line test, that doesn't work. And this one, that doesn't work because it goes all over the place. So you know it's not C. If all three of them C, you know it's not. But what about this one? Okay, from negative infinity to -5, it is 1-to-1. But not 1-to-1 from negative infinity to -5. Say you hit it twice. So it's got to be this one. Why isn't it this one, Hubert? Well, because this one, if you go from negative infinity to -5, you could draw your line down here, you're going to hit it twice. So that's not it. Here, it goes past -5. It goes over here. It's over here, and that's 1-to-1. That's not it. This one's all over the place. So it's got to be D as in delta. Let's do similar question, since this is a good test question. Determine which graph as a function is 1-to-1 from negative infinity to 3. Negative infinity to 3. Right here. But not, so it's not this one. Negative infinity to 3. It could be this one. Could be D, or it could be this one. Negative infinity to 1, 2. Nope, it's not that one. It's not that one. It's got to be D. Yep. So you just got to use your horizontal line test and read your domain. Negative infinity to 3. Negative infinity, 1, 2, 3. Right there. Okay. It's a good test question. Not a lot of math involved. Let's see, 1.3, number 9. I saw a number 9 down here. There's a 5. 1.35. Okay, y'all sending me questions now. 1.353. 1.353. Okay, is this function 1-to-1? Well, it's not right in here. It's not 1-to-1 from like -4 to 0, because if you draw a horizontal line test, you hit it like 3 times. So the only place is, there's 1-to-1 right here, and then 1-to-1 above here. Let me show you. Let me draw it for you. This is 1, 2, 3, and this is 4. 1, 2, 4. I'm going to try to draw it halfway decent. All right, here we go. Up, down. There we go. So here's fun, and this is a test question. It's supposed to be kind of U-shaped, but you get the idea. All right, there's the function. And right here, let's draw our horizontal lines. And draw it right here. That's a 1-to-1. That's a 1-to-1. Right up until you get right below that. That's a 1-to-1. That's a 1-to-1. And this is 1-to-1, 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 1-to-1. But this right here is not 1-to-1 because you crossed it twice, 3 times. See, there's 3 times. And you get the idea. This one right here, twice. So basically, right here to number 4, that right there, that's going to be 1-to-1 down here. So I guess you could say from negative infinity to -4 on the y end is a 1-to-1. And then from 0 to infinity on the upper end of the y is 1-to-1. So horizontal line test, and that's probably what they got. From negative infinity to -3, I'm sorry, -3, and then from -3 to -1, find 3 intervals which, okay, they're using the x's. So negative infinity to -3, and then from -3, I got mine drawn wrong. I thought I had it drawn correctly. I got it drawn wrong. That's supposed to be a -3 right here. That's -3. Okay. I'm trying to see if I got it drawn correctly. Yeah. 0 to -3. And then from -3 to -1. Yeah, that right there, this piece right here, but you can't go all the way across. Okay, this piece right here, you can do it right here. They're including that little piece. Right here, you can do that piece, that piece, that piece, and that piece. So, but you can't include all 3. So from here, from negative infinity, I don't like this question, to -1, you got there. That's a 1-to-1. And then from -3 to -1, you got this one. And then from -1 to positive infinity, you got this guy. But you cannot use this area right here for all 3. I don't like that question. That one's kind of tricky. So I wouldn't use that as a test question. And plus, these are not really a lot of mathematical questions. Let's move down to number 9. I'd like to get different quotients. This is number 9. Let's see who sent this one. Let's see, 1.395. 1.395. Find the inverse of the function y is equal to 6x. All right, this is real easy. And all I'm going to test you on with inverse is to make sure you can find it algebraically. F of x is equal to 6x. This is how you do it. F of x is equal to 6x. First thing you do is you write it like back in pre-algebra. Change that f of x to a y. Y is equal to 6x. Now what you do? Switch the x and the y. So this is x is equal to 6y and solve for y. So y inverse is equal to x over 6. Now that's what I will test you on. I don't care about all these Philadelphia lawyer questions. All I care about is you be able to find the inverse of 6x. And what does the inverse look like? Well, we'll do it. Let's do it on the calculator. Take our handy dandy calculator. Y'all sure are quiet. What's the matter with y'all? Cat got your tongue? Yeah, Hubert, we don't feel like talking today. Okay, thank you, class.
It's Monday.
Okay, well, you got to get over that. The Tide Pod generation needs to get over it's Monday and it's 8 o'clock because you're going to have to work the rest of your lives. So you might as well just get over it. Unless you're going to marry a sugar daddy or a sugar mama or both, or however you swing, that's fine. You know, whichever way you want to roll. Not a comment. I figured I'd get something out of that. Nothing. Weaned on a pickle. Y is equal to 6x. And I'm going to do 6x in blue. And then I'm going to do in pink, I'm going to do x over 6. Y is equal to x over 6. And graph. And of course, that gives you nothing. Zoom, standard 6. And you see that the lines are opposite of each other. The x is equal to the y, and the y is equal to the x. Everybody with me? So if I hit trace on the blue line, let me go to, I was trying to find, all right, let's just pick that point right there. And I'm going to draw this line on the graph here. This is how you know if you got an inverse. I'm going to draw the blue line, and I'm going to use that point right there. And that point is 0.7576, comma, 4.545. Now, what will the inverse have? Well, the inverse is in pink. Let me find my pink marker. And this point right here will be 4.545, comma, 0.7576. So write this down. This is how you can tell if you have inverses of each other. The x will be the y, and the y will be the x. That's how you tell. So let's look. The blue, we got 0.7575, blah, blah, blah. Now let's switch over here and go to 4.545. And look at there, 0.7576. Ain't that neat?
Yes.
And that is a test question, so make sure you know what I just did right here. This right here is a test question. I want you to be able to do this. So let's look at another one right there because those are two good test questions. Let's look at another one. That was number, hold on. That was number 9. Here's another one from another student. Let's look and see what it says. Same problem, another test question. It's probably going to be different numbers. Y is equal to 5x. Same, just different numbers. F of x is equal to 5x. Y is equal to 5x. Switch the x and the y and solve for y. Y inverse is equal to x over 5. So there's two good test questions. course, they may get a little bit more complicated, but still the same thing. You write as y is equal. Then you switch the x and the y and solve for y. Y'all settle down, please. All right, next question. That was number 9. So let's go up here and find one close to number 9. I don't see any. So now we jump from number 9 to number 59, I guess. Well, there's a 49. Let's see what that one looks like. Solve this or I'm quitting school. Oh, that's mine. Is that mine? No, that's not really. I thought I was writing that for me. All right, so this is 1.3 49/17. First of all, is it a test question? No, not really. I mean, it could be. It says if log base b of x, log base b of x is equal to 0.37, and log base b of z is equal to 0.83, evaluate the following expression. Evaluate log, I'm sorry, I can't write, log base b of the square root of x over the square root of z. Everybody got it?
Got it.
Well, first thing you want to do is rewrite this, because this is something right here that needs to be reworked because it's got a dividing symbol. So the quotient rule is going to work here. You could do log base b of the square root of x minus log base b of the square root of z. And y'all all know that that's using the quotient rule of logs. And now you change this to log base b of x to the 1/2 minus log base b of z to the 1/2. And you can pull that 1/2 out front and then factor it out. 1/2 log base b of x minus log base b of z. And what's log base b of x?
0.37. I don't know.
And what's log base b of z?
0.83. How we go from 1/2 to 1/3?
Because I'm on medicine, I guess. I don't know. I'm just drunk. Let me give me another drink. So now that's going to give us 1/2. And 37 cent minus 83 cent is going to be what? 13.6 and 46. Somebody help me out. What's 0.37 minus 0.83?
It's negative 0.46.
Okay, and then half of 46 cent is 23 cent. So the answer should be 23 cent or 0.23. Why do I keep saying cents? Because that's what we think in terms of money. When we see a decimal, that's what we think about. Unless you're just weird and you don't think of money. Like Mr. Pangella, he probably thinks of, I don't know, molecular buildup or something like that, Mr. Pangella, don't you? Pagella, sorry. molecular formation of hydrogen. All right, so let's see if we're right. Let's make ourselves feel good. 0.23. Oh, now I hope I did it right.
I think it's going to be negative. Or never mind.
Okay, somebody check my math. Log base b of x is 0.37. Log base b of z is 0.83. I got 0.23. Why did they get 0.097? I must have done something.
Z is to the cube root. Did we do that?
Say again?
Z, it says Z is to the cube root. When it's x over z.
X over z, that's, oh, cube. I suck. Okay, I just did a different problem. Let me do this problem. I'm going to do this problem over. My bad. Thank you. Who said that? Who said that?
Mr. Parrish. I did. Me.
Okay, me, Mr. Who?
Parrish, Tobias.
Mr. Parrish, you're a good man. Log base b of the square root of x over the cube root of z. My bad. I must have thought it was the square root of both. That's what I was thinking. That's a cube root right there. So let me start over. I'm sorry. That's what happens when you don't read the question right. In my defense, I am a guy, so it is in my genes not to read directions. X is equal to 0.37 and log base b of z is equal to 0.83. Okay, so let me redo the problem. This time I'm going to not use 1/2 for both of them. So log base b of the square root of x minus log base b of the cube root of z. Log base b of x to the 1/2 minus log base b of z to the 1/3. Now we can't factor out 1/2, but we can put the 1/2 out front of log base b of x minus 1/3 log base b of z. And that's going to be 1/2 times 0.37 minus 1/3 times 0.83. And that's going to be 0.37 divided by 2 minus 0.83 divided by 3. And 2 will go into 37 cent. Dang old 18.185. You know, check my math there.
That's right.
And then this right here minus 3 will go into 0.8. 0.2 times 0.2 will leave 23. 3 will go into 23 7 times and leave 3, I guess, 0. I don't know. And then 18.5, that's going to be a minus, let's see, 5. 17 minus 8 is 9. And then 0. I got 0.095 without a calculator. What was the answer?
It was like 0.091 something.
Okay, well, that's good enough for government work. I got it close enough. Okay, 0.0917. Okay. So it kind of helps to read the directions. Guys, make sure y'all read the directions and not mess up like I did. Point, calculator, negative 0.0917. Let's do another one of those. See if we can find another one. That's a good, this is a test question. See if I can find another one. I don't see another 49. I'm looking for something close to 49. I don't see another one, so we'll just move on. I guess 59 would be next. Good gracious, what's that noise? You sound like you're moving cabinets or something. Okay, I'm gonna have to mute whoever that is. Boy, that's annoying. I think I muted the right person. Okay. Oh, this is a test question. If you don't know how to do this one, you're a loser. 2 to the 3x plus 4 equals 18. Now, what should you do before you even start this problem? First thing you should do is see if 18 can be written. See if 18 can be written as an exponent. Let's see, 2 times 2 is 8. 8 times 2 is 16. 16 times 2 is what?
32.
Okay, it can't be written as a 2, so you can't rewrite it. So I'm going to take the log of both sides. Log of 2 to the 3x plus 4 equals log of 18. Now I'm going to give you 2 for the price of 1. I'm going to do this problem this way because I can't change 18 to 2 to the whatever power, so I've got to take the log of both sides. You can also take the natural log, it doesn't matter. 2 to the 3x plus 4 equals 18. Natural log of 2 to the 3x plus 4 equals natural log of 18. Okay, you can do it, I don't care, 6 of one, half dozen the other. Doesn't really matter. Bring that 3x using the power rule. Bring it out. Should you know the power rule of logarithms? Yes. 3x plus 4 times log of 2 is equal to log of 18. Well, this is the same thing as a number. So I'm going to divide by the log of 2. So 3x plus 4 is equal to, somebody take the log of 18 and divide it by the log of 2 on your calculator, please. And give me 4 digits if it goes that far. I'm waiting. Oh my God, I'll do it myself.
I got 4.1699.
All right, well, I've already got my calculator up now. I do appreciate it. I do appreciate you finally answering. So I'm going to go ahead and check you. Log of 18 divided by log of 2. And you were, I don't think you were correct. 4.17, is that what, everybody got that?
Yeah, that's what I got.
And now look what you got. You got a regular old what? Pre-algebra problem. -4, -4, 3x is equal to 0.17. So -4 and divide by 3. I got 0.0566. What'd y'all get?
Got the same thing.
And let's check it. 0.0566. Yep. They probably want the square root. I don't know how you're going to get. Oh, they want log of 18 divided by log of 2 divided by 3. No, I don't know what they want. Yeah, they want it written out. And you could do it like that, but I don't, for the test, all I care about is final answer. I really don't want that. So log of 9 divided by 3 log of 2. Yeah, that's drawn out. -1. If you do this on your calculator, you're going to get 0.0566. Now I'm going to give you one, and this time you don't have to take the natural log of both sides. Take the same problem, and I'm just going to change one thing. 2 to the 3x plus 4 is equal to 32. All right, you do this one. You don't have to use the logarithms. All you got to do is use exponential laws. 1, 2, 3, 4, 1. Why'd you turn off your videos, people? Turn them back on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, now the reason I want you to turn those on is so I can see whenever you leave the room, and I need you to pull them down a little bit. So when you leave the room to go back to sleep, or you leave the room to go eat breakfast and you never come back, I will know that. So, Miss Jones, you need to pull yours down a little bit where I can see you. I appreciate it. Thank you. All right. So this one, you don't need to take the log of both sides. This one, you just do 2 to the 3x plus 4 is equal to what? 2 to the 5th. And what happens when your bases are the same? What happens when these bases are the same? What?
They cancel out.
They cancel out, and you let the exponents equal themselves. -4 minus 4, x is equal to 1/3. So, if you're able to change that number into the same base, go for it. But if you can't change it to the same base, you're going to have to take the log of both sides. Another way you could do it is the definition of a logarithm. What is the definition of a logarithm, Hubert? Well, y'all should know this from 109 and 110. And if you had me, you should remember it. Y is equal to log base A of x. A to the y is equal to x. This is the definition of a logarithm. Definition of logarithm. And you can write like this, or you can write it like this. Either way. So here I have A to the y is equal to x. A to the y is equal to x. So A is equal to 2. Y is equal to 3x plus 4. And x is equal to, let's go with this one right here, 18. So since I've got all that, I can rewrite this, the exponent. I can rewrite the exponential equation as a logarithm. My y is 3x plus 4 is equal to log base 2 of x 18. And 3x plus 4 is equal, change base formula, log of 18 divided by log of 2. And then 3x is equal to log of 18 over to log of 2 minus 4 divided by 3. And you could rewrite that. This is 1/3. Dividing by 3 is equal to 1/3. So you could rewrite that as 1/3 x is equal to, you could rewrite this as 1/3, that's 3, 1/3 times the log of 18 over the log of 2 minus 4. And you could actually get this, that's the log of 9. So you could actually log of 9 minus 4 over 3, and you could rewrite it several different ways. So hopefully you're brushing up on your logarithms, because logarithms, you know, that's part of algebra, and this is an algebra review. Let's look at another homework question. See, there's the 1/3. See, 1/3 log of 9 over 2. That's supposed to be log of 18 over 2. I think somebody's got an error there. I think there's an error there. Let's do another one. That's 59. Let's do 65. 65. This is exponential involving logarithmic functions. 65. 65/21. 1.365/21. The height and feet of a baseball play of a baseball hit straight up from the ground with initial velocity of 224 feet per second is given by h, which is function of t, time, which is equal to 224t minus 16t squared. Okay, first of all, we're going to look at this. I'm not going to answer any questions. We're just going to, that 224, you could write that down, but that's a red herring. 224 is given there, so you can put it right there. So this is the only thing you need to worry about. That right there is the only thing you need to worry about. And we're going to do this on the calculator because it'll be easier on the calculator. This right here is a calculator drill. You want to be able to find the y-intercept, the x-intercepts, and you want to find the vertex. Now, we could do this by completing the square, okay? And some of y'all would have fit, some of you wouldn't. But just to show you how we would do that, we would go over here and do it by hand. Again, this is a review, so I'm just kind of throwing everything out there, and then you know, negative 16t squared plus 224t plus blank is equal to 0 plus blank. And factor out a 16. And I don't know if 224 is divisible by 16, but we'll find out right quick. 224 divided by 16, please. Yes. Okay, so that's going to be t squared plus, be a minus, sorry, minus 14t plus blank is equal to 0 plus negative 16 times blank. And the rule is whenever you complete the square and you have to factor out something, why'd you have to factor out that 16? Because in order to complete the square, you got to have a 1 in front of that t squared or the x squared. You got to have a is equal to 1 before you can complete the square. So I factored that negative 16 out, and whatever I factor out here, I have to multiply it by this right side blank. And that's just the rule of completing the square. Half of 14 is 7. 7 squared is 29 or 49. And that's going to give us shortcut number what? Number 2. Negative 16 times t minus 7 quantity squared is equal to, oh me oh my, 16 times 50. I don't know. I'm trying to think out loud. But that's 49. So 16 times 49. I'm not going to ask y'all because it'll take y'all 20 minutes to tell me. 16 times 49. I got 784. So that's negative 784. So my vertex is 7, 784. So that's the highest point that the ball goes. That the ball goes up. It goes up to 784 feet in the air at 7 seconds. At 7 seconds, the ball is 784 feet in the air. Now find the x-intercepts. Divide by negative 16. Divide by negative 16. T minus 7 squared is equal to 784. 784 divided by 16. 49. Take the square root of both sides. T minus 7 is equal to positive or negative 7. 7 plus 7 is 14. 7 minus 7 is 0. So the ball is on the ground at 0 seconds and 14 seconds. And the y-intercept is 0, 0. Now see, I just did completing the square by hand. And all of you that had me for 109 or 110 should be like, oh yeah, he told us how to do that like 5,000 times. If you didn't learn how to do completing the square, you didn't get your money's worth out of your algebra class before this class, whether it be in high school or college. Question, gripe, complaint.
Got another one?
We got to do it by the calculator now. Okay, so write down this information. This information is what you need. The y-intercept and the x-intercept. Luckily, the y-intercept is right here. There's the y-intercept. It's also an x-intercept. And the vertex. And it's opening downward, which is a negative. So before I do it on the calculator, I'm going to draw a big graph. 0, 0, that's where we throw the ball. We throw it up in the air. What goes up must come down. And that's 14. There was actually a song way back before my time. What goes up must come down. Vertex vertex is 7 seconds at 784 feet. And now let's do the calculator. So let's take our handy dandy calculator, and I want to make it small because I want us to see our drawing as we do the calculator. All right, y is equal to negative 16 x squared plus 224. And I'm going to clear that one right there and graph. Well, that don't look right. I don't think that's right. Zoom, 0. Now, that's not right. I can't throw the ball from a negative. Let me look back what I did wrong. Negative 16x squared plus 224. Something's not right. Negative 16x squared Is that right? No, it didn't like that. Okay, I must have something wrong. I've got something wrong somewhere. You're supposed to be throwing from 0, 0. Hold on a second. I got to find out why I'm wrong because I don't get completing the square wrong. Negative 16t squared plus 224t. Okay, I'm going to check my math right quick. 16 divided by, or 224 divided by 16. 14 divided by 2 and square it. 49 times negative 16. Negative 784. I don't know what to tell you. Has anybody gotten the same thing I got?
Yeah, I did.
Did you get this?
Mm-hmm.
I don't understand what I did wrong.
In your y equals on the calculator, you had just 224. You didn't have 224x.
Whew, thank you. Thank you very much. Whoever that was, I'm going to give you an A for the class. I'm just kidding. Thank you, thank you, thank you. Well, as soon as this rickety calculator comes up. What I was trying to show you is you can do it both with the calculator or completing the square. And you were right. Thank you. X. Now hit graph. Phew. I was trying to figure out how you could throw from the negative. That's like throwing from the fourth dimension. Zoom 0. And zoom standard. Nope, they don't like that. Zoom first quadrant. Y'all didn't know you could do that, did you? Well, that sucked. Let's do the window. X min, -5. X max, 15. 0, -1, or -5. And Y max, 800 feet. And enter and graph. There you go. And remember, what goes up must come down. So there's your vertex. So let's check it with trace. Second, trace. And I want to find my max. So give it a left bound and a right bound to search. That way it narrows the search. And give it a guess. And there is your 7,784. And let's find this point right here. So that would be second, trace, 0. And go down here and just give it a left bound. Don't hold your button down. Hold on. And the right bound. And give it a guess. And 14 and 0, that's how you find your points on the calculator. But make sure you put an X beside that 224 or you're going to go crazy trying to figure it out. That is a test question. Now, let me ask y'all a question, just volunteer, because I know my 109 and my 110 students that I had, I know we spent like a week on completing the square. So I know they know it. But how many of you had teachers never show you complete the square? Anybody? Miss Brown? Anybody else? Put your virtual hand up if you've never seen completing the square before. Virtual hand? Anybody? Okay, so most of y'all have seen it. Okay. All right, well, let's keep going. Let's keep trudging. That was 65. Let's see if this one is same type. Let's do this one. Probably change the numbers a little bit. And we only got like 4 minutes. All right, do that one. -16t squared. Do it on the calculator. H of t is equal to -16t squared plus 288t. Go ahead and do that one on the calculator and find the vertex and where the baseball hits the ground. All you got to do is change a couple of numbers on the last one we did. Okay, so take your calculator. And y is equal to negative 16x squared plus 288. Graph. And you need to zoom out a little bit. Zoom out. And you can redo your numbers or whatever. I don't care what you want to do. Just back it. Just get it right in the middle, kind of. And hit enter. There you go. And second, trace. Get your maximum, which is your vertex. Do a little bit left. Do a little bit right. Narrow it down. Give it a guess. And there is your, so at 9 seconds, what's the height of the baseball? (1,296 feet, Hubert. Thank you, class. Appreciate the interaction. Second, trace and intersect, or 0, sorry. And don't hold the button down, whatever you do. Left, right, give it a guess, and enter. And at 18 seconds, the ball is what? The ball lands. So for a test question, you could just do this on the calculator and just find the vertex and the x-intercept. Capiche? Okay, now we didn't get all the way through 1.3. So what I will do in the next class, I will try to get these three, or get these two done, 76 and 85, okay? I'll get 76 and 85. I'll do that first in the next class. So, I don't know, let's see. These are all 1.3 people. Okay, so, no, 3, yeah. All of them are in the next class anyway, so I'll get to those in the next. There's 1.4. Damn it. Okay, I'll go over 1.4 tomorrow. I knew we had 1.4, but I couldn't find the questions. Good gosh. Wait a minute. Why are they all the same? Mr. Silva, why'd you send me 500? They're all the same. Oh my gosh, look at that. Sent me like 100 questions of 1.440. I don't understand. All right, let me take the roll. Now, what should you be working on? You should be working on 1.1 through 1.4 and be watching for that chapter 2 homework to hit whenever I finish it. There's the recording.